get started with the lesson. Are there any questions on any of the assignments thus far? Now, what we're starting today is solving polynomial functions and really solving quadratics. Well, not quadratics, but anything bigger than a quadratic and including them. And the way that we've gone over solving so far, well, was by graphing, because we use graphing to be able to solve our quadratics. Because that was one of the first methods we learned about solving any type of polynomial function. Well, the next method we had, especially with quadratics, was factoring. And then we had completing the square. And the quadratic formula. Yeah. I think y'all can read that a little bit easier than my handwriting. Were the four main methods that we had for solving. Now, these two here mainly work on polynomials of degree 2. There is some ways that we can manipulate them and work it with some that are degree 4 or higher, but it requires a little bit more manipulation to be able to use them. However, factoring and graphing can work on these higher degree polynomials. Unfortunately, we didn't have enough time to really delve too far into factoring, actually being able to factor these higher degree polynomials. But graphing is a great way that works. And if we can get it down to a degree 2, then we can use the quadratic formula or completing the squares to finish it out. Any questions on this here so far? Pulls it up. So you will need a graphing calculator today if you don't have one out already. There we go. Okay. Same quick. Now once you do full screen. So, what we're looking at this here, in these first few, it does say by factoring, but we're not going to solve them by factoring, mainly because we didn't go over that method. But how we solve these and how we solve quadratics isn't going to be too big of a difference. It's really, we're trying to find the values of x that make this function equal 0. That's what we want to find. So we can actually graph it to see what the zeros are, what the solutions are. So what we can do is make sure, one, that all the variables are on one side of the equation, everything's on one side, and it is set equal to 0 for us to be able to graph it. And when we graph it, we're going to take the graphing calculator and hit y equals, well, here I'm going to need to clear both of these out. And on the first line, we can type it in as 2x to the third minus 12x squared plus 18x. And once we get that typed in, we can hit graph. And if we hit graph, we're trying to see where it's 0. Well, there are 2 places where it's 0, yes? Well, we can say second graph to look at the numbers. Well, we have a 0 at 0, and we have a 0 at 3. Because we're not looking for where x is 0, we're looking for where y is 0. So we have 0 and 3. So here we can say x is equal to 0 and x is equal to 3. Now, because this is a cubic degree 3, there is actually one more 0. Y'all know what it would be? Well, one way we can see if we can find it is with synthetic division. Because each of the numbers that we were plugging in with synthetic division, if it gives us a remainder of 0, is a solution. So we can try this with the 0 first. So the numbers going across the top would be 2, negative 12, 18, and 0. We can drop the 2 down. And well, 0 times 2 is? Negative 12 plus 0 is? 0 times negative 12 is? 18 plus 0 is? 0 times 18 is? And 0 plus 0 is? 0. So we have a remainder of 0. Now it started out as a degree 3, and as we mentioned yesterday, each time we do the synthetic division when we have 1, it reduces the degree by. So now our new equation here with the 2, negative 12, and 18 is now a degree 2, yes? So we could do this again. Well, I grab a different color. So what number can we put in the little box? 3, because that was the other 0 we found, yes? And the first thing we would do is drop the 2. So 3 times 2 is 6. Negative 12 plus 6 is? 3 times negative 6 is? And 18 plus negative 18 is 0. Do I have any other numbers to work with? So let's put the variables back in. Now the 0 would be the remainder. Our negative 6 would be the constant, and 2 would be with. So what I'm saying that I have left is that 2x minus 6 is equal to. Can we solve that? So how would we go about solving this? Let's rub this a little bit. So we could add 6. And x is also equal to 0 and. So 3, 3, and 0 are all the solutions. So it worked out that 3 was a solution twice. If it is a degree 3. We can, because we can have multiple. I don't know if they're in the first few, because on the back of the first page, we do have a degree 4 and a degree 5. So let's look at this one here. And let's do this one a little bit differently, because we can graph it and get solutions. But let's just look at it and see if we can see a solution already. Because we have this equation, 5x cubed minus 40x squared plus 80x is equal to 0. What value do you think we could plug into all three and get 0? 0, because if I plug 0 into 5x cubed, what's it going to become? How about negative 40x squared? 80x. Because do I have a constant term? Do I have a number without x? No, so if there are no constant terms, most likely x equals 0 should be a solution. Well, we can check it with synthetic division, yes? Because we can put 0 in the cubbyhole, and across the top would be 5, negative 40, 80, and 0. Bring down the 5. 0 times 5 is 0. Negative 40 plus 0 is negative 40. 0 times negative 40 is 0. And 80 plus 0 is 80. 0 times 80 is 0, and 0 plus 0 is... So it is a solution because when we know that the remainder is 0, it is a solution. Questions on this here? So now we do have this here. Instead of graphing it, I'm going to plug the variables back in. Because we have what? We have a quadratic, yes? Now we could complete the square, but why not? Use the quadratic formula. Because that will get it just the same, won't it? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Looking at this here, the value of b is what? So we would have negative 40, or we could have just put positive 40. Inside the parentheses, we'll have negative 40 squared minus 4 times a, which is 5 times 80. All over 2 times a, or 2 times 5, which we could have written as 10. Any questions on how we plug this in? Or plug the values in? Now, as we just said, negative 40 is just going to be positive 40. Now, in the denominator, 2 times 5 is 10. Now, what I would do first, and let's see if I can even, nope, still won't let me use the highlighter. I can plug everything inside the radical into the calculator first. I would leave the radical off for now, just in case it doesn't work out evenly, or if it's a negative. As 40 squared would be 1600. As 4 times 5 is 20, and 20 times 8 would be 1600, which would be 0. All right, challenging question. What's the square root of 0? Zero. Now we could break this up into the two groups, because we could say 40 plus 0 divided by 10, or we could have 40 minus 0 divided by 10. Well, 40 plus 0 is, and 40 divided by 10 is, well, 40 minus 0 is still, and 40 divided by 10 is. So our solutions for this here is x is equal to 0, 4, and could we have graphed this and got those three answers? Because graphing works well if the answers are whole numbers. Because if the answers are whole numbers, then it will give those to us. Any questions on any of this here so far? Now, finding the zeros of the function is going to be the exact same thing. Now, there is a way to be able to actually factor this if we wanted to, but we haven't covered that yet, because it would be using something called the u substitution, substituting x squared in for u. But what we can do also is we can graph it and see if there are any solutions that graphing will give us. So we can clear this out, and we can type it in as negative 2 x to the 4th power plus 16 x squared minus 32. And then we can graph it. Are y'all able to get something that looks like this here? Kind of looks like a W. So we need to see what those two values are. So we can go second table. So we're looking at negative 2 and 2. Yes? It's something that looks a little different. Okay. Yeah. So we do know that those two are the solutions, yes? So we can come back over here and say x is equal to negative 2 and 2. Well, this is a degree 4, and we'll cover it eventually with chapter 4.6 exactly why it's going to be 4 solutions. And that's dealing more with the fundamental theorem of algebra, why that works out. But we do need 2 more solutions. You all have a guess at what they are? Wouldn't be 0. So let's do synthetic division and break it down. So we would have negative 2 for x to the 4th, 0 for x cubed, 16 for x squared, 0 for x, and negative 32. Drop down the negative 2. Well, negative 2 times negative 2 is 4. 0 plus 4 is negative 2 times 4 is negative 8. 16 plus negative 8 is 8. Negative 2 times 8 is negative 16. 0 plus negative 16 is negative 16. And negative 16 times negative 2 is, which gives us all right, what number do we want to do next? Bring down the negative 2. 2 times negative 2 is? Yep, you're good. 2 times negative 2 would be negative 4. 4 plus negative 4 is? 2 times 0 is? 0. 8 plus 0 is? And negative, or 2 times 8 is? And negative 16 plus 16 is 0. So we got down to this here. Now this is, what degree do we have now? Second. Degree 2, yes? So we could use the quadratic formula possibly, or any of the methods we had for quadratics to solve it, yes? Does anybody have a guess at a number that it might work? If not, that's fine. We can move on to the quadratics. Okay. So 8 would be the constant term, 0 would be the term with x, and negative 2 would be the term with x squared, yes? So what do we actually have? 2x squared plus 8 is equal to 0, yes? Now we could use the quadratic formula and that would work, but did we have another method for solving ones like this? Because it doesn't have a middle term, does it? So couldn't we use the square root method? Move everything to one side and square root it. So the first thing we can do is subtract 8 from both sides, which will tell me that 2x squared, these will cancel, is equal to -8. Then what would we do next? Divide both sides by -2. X squared is equal to 4. And last but not least, we would almost x would equal plus or minus 2. So the solutions for this here are x is equal to 2, 2, and -2. Because what did the graph do at 2 and -2? Did it actually cross the graph, or the x-axis? No, it came up, hit that point, and went back down, yes? That means that both of these here, it has what we call an even, hopefully I spelled that right, even multiplicity. That means that there's an even number of zeros at that location. 2 is an even number, so we could have 2. We can have multiples there. So really, if we wanted to, and I was seeing if anybody would see that, I'll erase this here. Because we do know that it works. Is that okay? I saw that it did cross, or didn't really cross. We could try 2 again. 2 times -2 is -4. 0 plus -4 is 2 times -4 is. And then we could have plugged x back in and solved it. Or we could do it again, or do -2 this time. -2 times -2 is. Now we're out of variables. We just have a number. So that's it. That would be all 4. Questions on this here? Find the zeros. So I'm not going to ask you to sketch the graph of the function, but we'll find the zeros of this here. X to the 4th minus 18x squared plus 81. So we can graph it. X to the 4th minus 18x squared plus 81. Now, on this one here, I want to, don't hit graph, do second graph. I just want you to pull up the table. I don't want us to look at the graph quite yet. Let's just look at the table. So if we look at this here, scroll up a little bit. So I do have zeros at -3 and 3, yes? Okay. So I'm going to come back over here. This here. X equals -3 and 3. Now we only really found 2. Most likely there may be repeated. We'll see. 1, 0, -18, 0, 81. Bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 18 plus 9 is negative 9. 3 times negative 9 is negative 27. Plus 0 is negative 27. And incidentally, it's actually negative 81, which is 0. So it does work. What other number do you all want to try next? Let's do it again. Let's do positive 3 again and see if this works. Bring down the 1. 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 9 plus 18 is, and 3 times 9 is, which gives us, it's repeated twice, because we have 3 twice. So we think negative 3 should probably be repeated twice. And we can check it to make sure by doing the synthetic division. Well, negative 3 times 1 is negative 3. 6 plus negative 3 is 3, yes? Negative 3 times 3 is negative 9, and negative 9 plus 9 is 0, yes? Well, might as well do it one more time. Negative 3 times 1 is so that tells me the solutions are 3, 3, negative 3, and negative 3. So, okay. Bless you. Do you mind if I erase this here? We got it all copied down? Yes? Okay. So what this told us is that x is equal to 3, 3, negative 3, and negative 3 are the solutions. And as we talked about in the previous problem, really when we have that double solutions where we have the same number as a solution, it's not going to cross the graph. It's going to touch the graph and go back up, yes? So, again, we haven't looked at the graph, correct? Or y'all haven't, hopefully? Okay, so let me select that. But I'm going to make a graph here. 1, 2, 3, 1, 2, 3, because I need to know that these are the solution points, yes? Now we know that the degree is even, and the leading coefficient is positive, yes? So that means it's going to open up, yes? So I do know that it's going to hit this point and this point here. And that it's going to eventually start coming up, so it's going to come down here. But it's got to come back up, yes? I don't know, I'll do something like this here. Then it's got to come back here, and we get this kind of shape, yes? Something like it. Go on and hit graph and see what we get. Now, how high up the middle bump was, it would be hard to tell just based off those two numbers, but we do get an idea of how the graph's going to look, yes? So what did we have? We just had the solutions, leading coefficient, and degree. We didn't need anything else. Questions on this here? And actually, this point here where it crosses the graph is going to be the point 0, 81. Because what's the x value when it crosses the y-axis? 0. Well, what's going to happen to x to the fourth when x is 0? It would be, well, 0, wouldn't it? What about negative 18x squared? That's the only thing that's left. 81. So that's where it would cross the y-axis. And then we would have the point here, -3, 0, and then we'd have the point 3, 0. And we can sketch somewhat of a graph. Questions on this here? Let's look at this one. I know I skipped one, but let's look at this one here. So we have 2x to the 5th plus 24x equals 14x cubed. Well, what's one thing we need to do first if we're wanting to graph it? Right, we need one side equal to 0. So I'm going to subtract 14x cubed from both sides. And what that will give us is 2x to the 5th minus 14x cubed plus 24x is equal to 0. And the first thing I would do is graph it. I would try graphing it, because if graphing will give us zeros, that'll make it easier to work with. So Gabe, what is one value of x that we expect to see to work out for this here? Because do we have variables in the entire side? We have 2x to the 5th, negative 14x cubed, 24x. All of them have an x, yes? So I do expect 0 to show up at least once. Come on. Clear. 2x to the 5th minus 15x to the 3rd. And I'm going to go on and just graph it. So we do have some places that it crosses. 2 of them don't look nice. Well, let's look at the table. So we have -2, 0, and 2. Now we do see that it does cross 2 more places, yes? But are they at whole numbers? No. So let's come back over here. So we said 0, -2, and 2. All right. Guess what we're doing next? Synthetic division. So we can do 0 first. 2 for x to the 5th. 0 for x to the 4th. -14 for x cubed. 0 for x squared. 24 for x, and 0 for our constant term. Drop down the 2. 0 times 2 is 0. 0 plus 0 is 0. 0 times 0 is 0. -14 plus 0 is -14. 0 times -14 is 0. 0 plus 0 is 0. 0 times 0 is 0. 24 plus 0 is 0. And lastly, we'll get our 0 and 0. Now, how many solutions did we say we should have? 5. How many times did we see that it crossed the graph?
3.
Because it came up, down, or let's pull it back up. Graph. Because I have 1, 2, 3, 4, 5 spots where it crosses, yes? Will any of these numbers be repeated? How many am I expecting to have? 5. How many places does it cross? 5 distinct spots, yes? So will any of the numbers show up twice? Well, no. So what that means for us is that 0, will it work again? No. So we can move on to 2 or negative 2. Which one do y'all want to do first? 2. 2 times 2 is? 0 plus 4 is? 2 times 4 is? 8. Negative 14 plus 8 is negative 6. 2 times negative 6 is negative 12. 0 plus negative 12 is negative 12. And 2 times negative 12 would be negative 24. And 24 plus negative 24 is 0. So what number can we try next? Negative 2. Well, negative 2 times 2 is negative 4. 4 plus negative 4 is 0. Negative 2 times 0 is negative 6 plus 0 is. Negative 2 times negative 6 is positive 12. And negative 12 plus positive 12 is 0. So that took it from doing that there, it took it from a degree 5 down to a degree 4, down to a degree 3. Now it's down to a degree 2. The 6 would be our constant term, 0 would be our term with x, and 2 would be our term with x squared. So what we're left with is 2x squared minus 6 is equal to isn't that nice? We have an equation. Do we have a middle term? So what method can we use to solve it? Square root method. So what can I do first to both sides? We can add 6. Because negative 6 plus 6 would be 0, leaving us with 2x squared is equal to 6. And then from here we can divide both sides by 2. This tells me that x squared is equal to, and then we would square root. Square root of x squared would be x is equal to plus or minus, because we can't simplify the square root of 3 any further than that there. So really our solutions are x is equal to plus or minus the square root of 3, 0, and, well, we can say plus or minus 2. And that would be it. Because really, for this here, since it is a degree 5, if we can find at least 3 solutions by graphing, we can find the other 2 with the quadratic formula or completing the square, or one of the methods that we have for solving quadratics.